we're going to look at critical points and increasing, decreasing. Okay, so we have got our critical points. Here's our definition of critical points. Critical points are points where the graph changes its direction or shape, which is kind of both. I mean, if you change your direction, I guess you're also changing the shape, but and then we have subcategories of critical points. We have extrema, which is your extremes. Extrema is just plural for extremes. Extrema are points where the graph changes direction. The function has a minimum or maximum value, relative or absolute, at these points. So if you notice, I'm going up, and then I switch to going down, so that makes that a maximum. I'm going down, I switch to going up, that makes that a minimum. So that's what your extreme values are, maximums and minimums. Then another subcategory of critical points is a point of inflection. Point of inflection is where the graph changes its shape, but not its direction. So notice I'm going down here. Here's my point of inflection. There's like a little wiggle, but I'm still going down. I didn't change the direction. Still on my way down there. It's just a little wiggle in the graph. So if you think you're going down quickly, we slow down and then we speed back up. So it's just kind of it's almost like a change in speed, but it's not a change in direction. Okay, does that help? So we're going to talk about the different kinds of maximums and minimums. So our relative and absolute extrema. So a point with the greatest value compared to points around it. That's the important part. It's not the greatest value overall, it's the greatest value compared to the points around it. So if you look at this point right here, this point is the greatest, has the greatest y value of the points right around it, just in its little neighborhood, okay? Because in a lot of things in calculus, we don't look at the whole graph. We look at just little pieces. We're just going to look at that part, just going to look at that part, that sort of thing. So when that happens, this isn't the greatest y value overall, but it is the greatest in that little area. That's a relative maximum. Relative. Because it's relative to the points around it. So relative, it can also be called a local maximum, but relative is probably more what you're going to hear. Then, the point with the greatest value over the entire domain, so the greatest value, period, that is your absolute maximum. So relative and absolute. Does that make sense? Then when we talk about the least values, so a point with the least value compared to the points around it, like this one right here, that's a relative minimum. Relative minimum. And then the point with the least value over the entire domain, that will be your absolute minimum. Okay, so I'm going to elaborate on that stuff just a little bit here. If we look at this picture here that goes with our relative and absolute minimums, and if I asked about a maximum value, this function has a relative maximum right here, because that's the maximum relative to the points around it. There is no absolute maximum because both of these go to infinity, and infinity doesn't count because it's not a value. You can't actually get there. Does that make sense? So infinity will never be your answer there. The other thing is this, and this can make this a little confusing. An absolute minimum is also a relative minimum. Because if I just give you a piece of the graph, let's say that I gave you the little domain and it was chopped off like right here. So all you could see is what's in between those two dotted lines I just made. You wouldn't know if it's absolute or relative, right? So all you know right then is that it's definitely a relative minimum. And so absolutes are relative and absolute. Does that make sense? So if I asked you, because this is the kinds of questions that are going to be on Delta Math, how many absolute minimums are there on this graph? There's one. How many relative minimums are on this graph? The answer is 2, because there's this one, and then that counts as a relative also, because it's both. Okay, makes sense to you? All right, any questions at this point? All right, so then this says, give the coordinates and classify the critical points for the graph of each function. Okay, so on number 1, how many critical points do I have? Just 1, okay? So I have this just the 1. Like I have x-intercepts, those aren't critical points. I have this one. This is is it relative, absolute, or both? Both. So I would say it's a relative and we can abbreviate, absolute. So relative and absolute minimum. And that point is at 1, 2, 3, 4. 1, 2, 3, 4, negative 5. If I asked you, what is the absolute minimum value? The value of the function is always the y value, right? That's your output. So the minimum value is negative 5. The minimum, when it asks, because this asks for the coordinates, it's at 4, negative 5. If it just asks you for the value, it's just the y value. Okay. We okay with that? Any questions? All right. How many critical points are on number 2? 3. So I have this point, and this point, right? So this first one is, first of all, is it a maximum or minimum? Maximum. Relative, absolute, or both? Both. So this is a relative and absolute maximum, and that's at negative 3, 1, 2, 3, 4, 5. Then I have this point. It's a minimum. Is it relative, absolute, or both? Just relative, because it's not an absolute, because see, this keeps on going, and so does this. So it's not the most overall, so it's only a relative. So it's a relative minimum at 1, 2, 3, 4, 5, negative 5. And then this third one, relative, absolute, or both? Just a relative maximum. Good. Relative maximum at 1, negative 3. What questions do you have? Anything at all? We good? All right. Let's look at the next one. All right, so on number 3, how many critical points do I have here? 2. I have this one and this one. Are there any absolute maximums or minimums on this picture? No, okay, because this goes to infinity, this goes to negative infinity, so there's not an absolute anything. But so that makes this point a relative minimum at 1, 2, 3, negative 3, 1, 2, 3, 4, 5, negative 5. Then what would the other one be? Relative maximum. And that is at negative 1, 5. What questions do you have? Anything? All right. How many critical points do I have in number 4? It's actually 3. Because remember, I have maximums and minimums, but then I also have this wiggle, right? So I actually have 3. I have this one. That is a relative maximum at negative 2, 1, 2, 3, 4, 6, negative 2, 6. This one, notice I'm not changing direction because I'm going down. I just wiggle and I'm still going down. So what's that one called? Point of, remember? Point of inflection. It's what your cubics have. And that's at 0, 3. And then this point would be a what? Relative minimum. And that is at 2, 0. What questions do you have? Anything? Okie dokie. So now let's talk about increasing and decreasing. Right? Now, before we even look at this, when we write intervals, the only time you put y values in your intervals is when you're talking about range. Everything else you do interval-wise is all domain stuff. It's all x's, okay? And you're going to have to remind yourself on this. You're going to want to do weird things sometimes, okay? So this says, moving from left to right, a function may increase, decrease, or remain constant on certain intervals. For example, the graph to the right is increasing, constant, decreasing. We'll talk about that. But the way in which you write these intervals is still debated amongst mathematicians. You can ask different mathematicians, different math teachers. They can have different takes on how you should do this. Okay, so we're going to do it in the same way that would be consistent with if you took calculus on this campus next year. Plus, it's the way that Mr. Ackerman and I both look at it anyway. If I say that I'm increasing, so increasing, I'm going from left to right. I'm talking about my y values. What is happening to my y values? My y values are increasing until I get here. Does that make sense? And then they remain constant. Well, what happens at this point? Am I increasing or am I constant? Or is that where I change, right? So it's, you know, you could argue either way. So we don't include it. You never include anything on increasing, decreasing, all right? Or positive, negative. The only time you worry about whether or not something is included is domain and range. All right, these are all open. So that means I'm increasing. I'm talking about y. My y's are increasing, but my x is going from left to right. So my x starts way out here at negative infinity, and it goes to negative 1. I'm increasing from negative infinity to negative 1. The fact that this y value is 3 means nothing. Okay? Then I remain constant from here to here. That's from negative 1 to 1, 2, 3, 4 to 4. So from negative 1 to 4, it's constant. And then starting at 4, and I know I'm pointing to negative infinity. My y goes to negative infinity, but I'm writing about x. I start at 4 on the x-axis, and all the way to when x is infinity, I'm still decreasing. So it's 4 to infinity. All right, so here's what I want you to jot down over here. What you are looking for is what happens to y as x increases. That's what we're looking for. What we write about are intervals of the domain. So you are talking about y, writing about x. Again, you have to stop and remind yourself of that every now and then, or you're going to want to write y's down. You should not be writing any y values down unless in an interval unless you're doing range. So let's look at what this says. This says, give the intervals on which each function increases or decreases. All right, so I can see here that my function, as I go from left to right, my y values, they're getting smaller and smaller and smaller here. Then they start to increase, but then they're also decreasing here. Does that make sense? So I start increasing. Yes, there's an arrow here. My increasing starts way out here. I write about x. It is increasing from negative infinity. Oh, that's not. That's a decreasing. I'm sorry. I just said decreasing, and I'm writing on increase. I'm decreasing here. Sorry about that. I'm decreasing. I start way out there at negative infinity. And I decrease until, what is this y value? I don't care. It doesn't matter. This y value is totally irrelevant. You are decreasing until you get to -2 for an x value. I'm going to have more than one interval, so I union it together. And then I start over decreasing again when x is 1, and it decreases until x is 3. Everybody okay with that? So then I'm increasing. As I go from left to right, my y values get bigger here, and they get bigger here. So yes, I start increasing from this point, but again, I don't care what that y value is. I start increasing when x is -2, and I increase until x is 1. Then I union that with, start back over when x is 3, and I keep going until x is infinity. What questions do you have? Left to right. You're going left to right the whole time. The only time you go right to left is in behavior. That is it. Everything else is left to right. Okay? All right, so then on number 6, what's on my graph that's not actually drawn on there? What do I have that, what does that graph have that's not actually graphed? Asymptotes, very good. So I have an asymptote right here, and I have an asymptote right here. Okay, so I need to figure out if I'm increasing or decreasing or whatever. So you just start to trace. I mean, you don't have to literally trace, you can like pretend trace, whatever. But I'm over here. As I trace along here, my y values are getting smaller and smaller and smaller, right? I'm never actually going to make it to 1, 2, 3, 4, 5. I'm never actually going to make it to -5, but it's decreasing starting way out here at negative infinity, and it decreases until we get to -5. But at -5, there's nothing there, so I can't say it's increasing, decreasing, or anything. So then, when I start back over on the other side of the asymptote, my y values are still decreasing. Oops, well, I sort of missed it there, didn't I? They're still decreasing. So I union that with -5 to infinity. And that can be kind of weird to wrap your mind around sometimes because this goes all the way down to negative infinity. Then you start up here at infinity, which is bigger than this number, but it didn't increase. It's as you go from left to right, your y values are decreasing the entire time. Okay? So there's no increasing at all. So we're going to say none. Number 7 also has an asymptote. It's right here. There's not one over here. This is like an exponential function. Is this function increasing anywhere? Yes. When I start way out here, as I trace along, it increases the entire time, right? So I start out here at negative infinity. I'm increasing the entire time, and that's until x gets to positive infinity. It's not decreasing at all. What questions do you have? All open. You don't even worry about, the only time you worry about whether or not something is included is if it's domain and range. The only time you write y values in your intervals is if it's range. That's it. Okay? Writing about x, talking about y. Any questions at all? All right, so let's look at positive or negative. So it says give the intervals on which each function is positive or negative. If the function is positive, that means the y values are positive. If the function's negative, it means the y values are negative. So everything above the x-axis is going to be positive. Everything below the x-axis is going to be negative because we're talking y values. If it is on the x-axis, then it is 0. It's not positive or negative. That's why we can't include it for positive and negative, right? Because then it's 0. All right, so if I want to see when is my function positive, well, right here, this is when it's all greater than 0, right? That looks like it because the arrows go this way, so clearly that's not going to go back up there. So this is positive. I don't care what this point is. My intervals are intervals of x. So I start right here at 1, 2, 3, 4. At negative 4, I do not include it because that would actually be 0. And it's positive from negative 4 to negative 1. Then it is negative here and all of that, right? So my function starts out being negative. Yes, this points to negative infinity, but I don't care about the y value. The smallest x value is going to be negative infinity. It's negative until it gets to here, which is at negative 4. I union that. I start back over being negative at negative 1 and go to infinity. Everybody okay with that? All right. So number 9, this part's positive, and this part's positive. This part's negative. See if you could get your intervals written. I'm going to give you a minute to write them on your own. Okay, so I'm positive. I have 2 intervals where I'm positive, right? So now I'm going to have to union something. It's positive. It starts out here. My smallest y value would be negative infinity. It's positive until it gets to here, which is at negative 1. Union that with, it starts off being positive again here. 1, 2, 3, 4, 5, 6, 7 to infinity. Do we agree with that? Does that make sense? If you didn't get that written down, do you understand why it should be that? That's okay. And then it's negative. Again, I really don't care what the y values are. It's negative starting at negative 1 and goes to 7. All right, now on number 10, this isn't actually part of the question, but I'm going to ask you anyway. This little point here where it wiggles, what's that called? Point of inflection. Everybody say it. Point of inflection. That wasn't everybody. Ready? 1, 2, 3. Point of inflection. Okay, if you've said it, you've heard yourself say it. Is that point right there a maximum or a minimum? Neither. It's not either one, so don't try and do anything weird with that. Okay, so now let's actually look at positive and negative here. Actually, you just do this. You figure out what's positive and negative, and you write them out, and I'll give you a minute to do that. Make sure we're getting our intervals written right. Because just because you know which one's positive and negative doesn't mean you're writing your intervals correctly. And that's important there. Oh, and you know what? This kind of goes, I forgot about this one. This one, we'll just say if it's not on a whole number, it's either on a whole number or it's at a 0.5. Let's go with that, okay? Instead of trying to guess. Yeah, this was a bad picture for me to choose, I know. Okay, so my orange stuff is positive, so that starts right here at negative 1.5, and I'm positive until I get to 0. Then I'm positive starting again at a positive 1.5 and going to infinity. We agree with that? And then I'm negative. Yes, this points to negative infinity, but the reason I start at negative infinity is because of my x. So I start at negative infinity, and I go to negative 1.5, and then I'm negative again from 0 to 1.5. Okay. What questions do you have? Anything? We all good? Awesome.